Welcome to the series of Radisys MobilityEngine RAN software solution videos. The intent of this video is to show a live demonstration of the Radisys eNodeB software functioning as a CBRS-based LTE small cell, which is also called a CBSD, Citizens Band Radio Service Device. The Radisys CBRS-capable eNodeB software, along with its expertise to provide custom development and test automation services, enables small cell vendors, system integrators, and service providers to accelerate commercialization of CBRS-based custom fixed wireless access, private enterprise LTE, and neutral host services. With Radisys CBRS-ready eNodeB software, demonstrated in this video, small cell vendors and service providers can cost-effectively deploy their own on-go compliant CBSDs. There are 4 key components involved in the demonstration. 1. A Radisys CBSD to create a CBRS small cell-based LTE radio access network. A CBRS-capable Radisys LTE small cell software has a built-in SAS agent that supports standard-based HTTP interface towards SAS, configurable CBSD, or LTE small cell mode of operations, and support for all CBRS procedures, such as registration, spectrum inquiry, grant, heartbeat, relinquish, and deregister. 2. A spectrum access server, an emulated SAS entity that supports all necessary WINNF-defined SAS interfaces and procedures, is used in this demonstration. 3. An evolved packet core. A Radisys EPC software solution is used to enable the CBSD to perform end-to-end LTE attach procedure on the CBRS band. 4. A user equipment that supports CBRS band and configured to attach with the Radisys CBSD. During the demo, you will witness a CBSD registration procedures with the SAS, followed by the procedure to attach a CBRS-capable UE with the CBSD, as well as the steps to verify that the CBSD transmits on the authorized CBRS channel. When the Radisys CBSD powers up, as part of the startup sequence, it triggers the registration procedure towards a SAS, which involves exchange of a series of HTTP/JSON messages on the SAS CBSD interface. As you can see in the Wireshark packet trace and event sequences, the CBSD has triggered the registration request, followed by the spectrum inquiry procedure, which starts with a spectrum inquiry request, followed by the spectrum inquiry response, grant request, grant response, heartbeat request, and heartbeat response. As part of the grant request, CBSD requests SAS, the list of available CBRS channels, which in this case is 3,610 MHz to 3,620 MHz. At the end of this procedure, the SAS entity has granted a specific channel and the CBRS band in which the CBSD is allowed to transmit. As you can see, the SAS has approved this grant in the response. Here is the CBRS band capable UE, which is configured to attach to the Radisys CBSD. Please note that since band 48 UEs are not available yet, we have used a band 42 and 43 capable UE, which overlaps CBRS spectrum in band 48. Let's trigger the attach procedure, which is simply done by switching off the airplane mode on UE. As you see on the screen, the UE is successfully attached to the LTE network. Let's look at the application installed on the UE, which confirms that the UE is attached to the LTE network over the SAS allocated CBRS spectrum. As you see on the screen, the UE is attached to Radisys CBSD over a SAS allocated CBRS band. Now, let's look at the application that translates LTE EAR-FCN number to the actual radio frequency. As you can see, the transmitted EAR-FCN used by the UE translates to 3,665 MHz uplink and downlink frequency, which is within the CBRS band. This successfully demonstrates that the Radisys eNodeB software fully supports all necessary CBRS modules, procedures, and interfaces that small cell vendors, system integrators, and mobile operators can utilize to accelerate the launch of CBSDs as well as CBRS network-based fixed wireless access, private enterprise LTE, and neutral host services. Thank you for watching our video. To learn more about Radisys CBRS software solution and expertise, visit us at www.radisys.com.